In this problem, we're asked to solve an algebraic equation. To solve an equation means to find all values of the variable that make this a true statement. So x represents any number, and for some values of x this will be a true statement, and for some values of x this will be a false statement, most likely. And so we're looking for the numbers whose square minus 3 times the number turns out to be 10. And the idea here is we don't want to search every possible number. That would be an inefficient way to go about this. We want to exploit the structure of this problem to find the solutions. And you may have seen this structure before, and if you have, you may know going into this that the number of possible solutions here could be none. It is possible that there are no numbers that satisfy this, or 1 or 2. But there will never be any more than 2 for a problem that has this given structure. Again, the structure relates to this square on the x. The solution technique for this that's most common here is to try and compare with the number 0, not with the number 10. So the first step I would take is to rewrite this as x squared minus 3x minus 10 equals 0. I'm just going to send the 10 to the other side. And again, the reason for this becomes obvious perhaps after the next step. What I would do next is try and factor this quantity, write it as a product. And what I want to do is then compare this product with 0. It's easy to figure out what numbers will make a product 0. It's more difficult to figure out what numbers will make a sum or difference 0. So again, this approach is an attempt to simplify our search. So what I need to do is fill in these blanks here. Again, that's not always possible, at least it's not always easy. So if this method fails, then I could use the quadratic formula, and I use this as my fallback. It's guaranteed to work, but it's a little bit time consuming, so I go after factoring first. And I give myself a few seconds. If I can see the factors, then I'm pretty much done. If I can't see the factors, then I go to the fallback, which is the quadratic formula. In this problem, since the leading coefficient here is a 1, I know that this first piece will be x plus or minus something, and so will the second piece, x plus or minus something. The product of these two somethings, these will be constants, needs to turn out to be negative 10. So I'm thinking negative 1 and 10, or 2 and 5, with one of them being negative. And I need to get a negative 3 as the cross term. And so from a 1 and a 10, it's difficult to build a 3, but from a 5 and a 2, it's possible. So I'll put a 5 here and a 2 here. And let's see, if I subtract the 5, this will be a minus 5x when I multiply this out. And then I'll add 2x back in, leaving me with the negative 3x. And again, you can check your work pretty quickly here. Just multiply this out and see that you get this same expression back. Now I'm dealing with a product of two numbers is 0. That's the way I view this. This is one number and this is the other, and the product is 0. So it must be the case that x minus 5 is equal to 0, or x plus 2 is equal to 0. And this is a classic divide and conquer technique. I've got a complicated expression. I broke it into 2 problems now instead of just 1, but each of these 2 are so much simpler that it's easier to do 2 simple than 1 hard. So now I will solve each of these. If x minus 5 is to be 0, then x must be equal to 5. You can either just see that or push the 5 to the other side and see it that way. Here again, I need x plus 2 to be 0, so x is going to have to be the number negative 2. And each of these should then satisfy the original problem, and it's